Today, I'm speaking with Matt Lowry, Director of Research and Development at Gill Corporation, for part 1 of this series about the company's new GillFISTS foamed in-situ thermosetting system technology. Hi, Matt. To start off, could you tell us how GillFISTS was developed?
Well, GillFISTS was developed when we took a look at the uses of honeycomb core versus foam core. Both of those types of core have been used for a long time in the industry, and each type of core has its advantages. Typically, honeycomb core is stronger and is used in more structural applications, whereas foam core is used where the end user had specific needs for thermal insulation or acoustic insulation, and that was where foam was really the strong point. So what we were trying to do was determine a way that we could take the advantages of foam core and incorporate those into honeycomb core. And up until the time that we developed this, that just wasn't possible to do without a lot of mess and a lot of objections by end users.
Why hadn't these enhancements been brought to market before?
Basically because no one had thought of a way to do it. Previous ways of combining foam with honeycomb, as I mentioned before, were really messy and involved a lot of dust, and the foam generally would interfere with bonding of the facings to the panel, and there were just a lot of objections to that. So we invented a way of incorporating foam into the honeycomb, and we did that by asking what if? What if we could somehow incorporate foam with honeycomb and avoid all of those objections? So we started working in the lab to try to figure out how to do that.
How did Gill work around these challenges?
So the way FISTS is actually done is we take a standard piece of honeycomb core and we do a secondary coating on the core. It's a proprietary formulation that we developed and invented at Gill. Once that secondary coating is on the core, then when the slice of that honeycomb is used to make a sandwich panel, whether it's a floor panel or a complex structure made with that honeycomb, during the process of making the part, usually a thermal process, and that thermal energy that's applied to making the part causes the foam to generate in situ, which means during the process of making the part. So during the bonding process where the skins are applied to the honeycomb, the foam generates in the cells of the core. So all of the objections are alleviated because all of that process happens in situ.
Thanks for taking the time to speak with us about GillFISTS honeycomb core, Matt. Make sure to check out part 2 of this vodcast series. For more information about GillFISTS or any of Gill's other honeycomb core and commercial aerospace products, head to www.mcgillcorp.com.